All right, so the question here was to try to write the sigma notation for the sum of this series. So there's a couple ways you can do this. Now, do you want to start with n equals 1? Do you want to start with n equals 0? What do you want your n value to start with? So that's usually the first place I begin. So I'm going to call this n equals 1, okay, which means that this is n equals 2, this is n equals 3, n equals 4, n equals 5, and n equals 6. Now, as I look at those, I want to start to kind of take apart the numerator and the denominator. Now, the nice thing here is that these fractions were not simplified. So they may in the future be simplified, and you have to kind of derive that pattern without knowing what the original fraction was. You know, like 2/4 could be simplified to 1/2. 6/8 could be simplified to 3/4, and so on. But we have the unsimplified version of each fraction. So let's talk about what's happening in the numerator as a separate entity and in the denominator as a separate entity. So in the numerator, that one might be a little bit tougher to see. So let's actually start with the denominator. I hope that you can see that we're taking 2, multiplying it by 2 to get 4. Taking 4, multiplying it by 2 to get 8, and so on. Now the way to look at that is 2 to the first power gives us 2. 2 squared gives us 4. 2 cubed gives us 8. 2 to the 4th equals 16. So 2 to whatever our n value is as a power is going to give us our denominator. So that's one place I can start. I know that my denominator is 2 to the nth power. The numerator is one that you'll begin to recognize in time. Maybe you saw that, you know, I take this and multiply it by 2 and I get 2. If I take this and multiply it by 3, I get 6. If I take this and multiply it by 4, I get 24. By 5, I get 120. And by 6, I get 720. If you don't recognize what's happening there, that's actually your factorial pattern. And that's a good pattern to remember. And I think that Mr. Middleman talked about that in the video, or I think I talked about that in the videos a little bit as well with factorials. You just have to be able to recognize that pattern. It's one that's going to show up a lot. So what I know is that in the numerator, I just have n factorial. Whatever my n value is, if I do the factorial of that, I'm going to get this term. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, and so on. So I have a good idea of what the pattern is, and now I just have to write that summation piece in there. So it's the summation from, we said from n equals 1 to n equals 6 of that expression. Now there were two other choices on your in your multiple choice question, and I want to talk about those. What if I had started out and said, instead of n equals 1, what if I said, let's make this start with n equals 0? Okay, so let's just redo each of these and make this n equals 0. Well, then this would be n equals 1, this would be n equals 2, 3, 4, and 5. If I had started with n equals 0, well, then n factorial doesn't make sense, right? Because n factorial doesn't give me 1. But if I add 1 to whatever my n value is, then it's going to make sense. So for instance, if I said take 0 and add 1, that's 1. 1 factorial is 1. Take 1 and add 1, that's 2. 2 factorial is 2. Take 2 and add 1, that's 3. 3 factorial is 6. So if I add 1 to each of my n values, I actually still have that n factorial pattern, or that factorial pattern happening. Now again, it doesn't make sense in our denominator to have 2 to the n, but if I say 2 to the n plus 1 power, that would also make sense. Because I shifted where the beginning of my series is from being at n equals 1 to n equals 0, I have to adjust my formula as well. But this formula works as long as I adjust my n values. And by the same reasoning, I could also say, hey, what happens if I start with, instead of n equals 0 or n equals 1, what if I start with n equals 2? So this is 2, 3, 4, 5, 6, and 7. Well, it's kind of the same idea, right? Now I have to adjust by subtracting 1 from every n value. So I could have said, you know, this might be, I'm going to write below here because I have a little bit more space, n minus 1 factorial over 2 to the n minus 1 power. And again, that's because I started my series with n equals 2, and now I'm going up to n equals 7. So this is just an example of how all three of those could be an expression for that series. There's actually an infinite number of ways I could express this. Generally, we're going to see this one kind of take precedence, usually starting with n equals 1. But we could write it in any form. So I just wanted to show you that all of those choices were applicable. And actually, there's many more that we could write here.